Hello everyone, this is J-Pop and I'm doing a very casual video right now. I'm gonna play some KenKen. For those that don't know what KenKen is, hopefully, so I don't have to explain this, hopefully you understand how Sudoku works. It's a number puzzle game. KenKen is like that, except it also has a mathematical factor to it, which makes it really interesting, and I actually find it quite relaxing. We're going to do the 4x4 just kind of right now. As you can see here, the rules of Sudoku apply, where each row up and down can only contain the numbers. As we see here, it's 1 through 4. So it can only be 1, 2, 3, 4. You cannot have 2 and a 2 in the same row, as well as vertical. And you also need to satisfy these mathematical answers that they have here. Some of them, like this 4 right here, this is indicating that A4 goes here. So that's what we're going to do. Let's see. Divided by 2. It doesn't matter which order you put the numbers in, whether it's like that or like that, as long as the number's inside. Okay. Oh, you got it, son. Oh, when I can't do any serious LPing, I play little things like KenKen to keep my mind going, keep me occupied, and, well, for anyone, I wonder if this will pick up in the recording. That was my son, so. Okay, anyway, back to KenKen. I'll clear out these numbers. So it doesn't matter whether the 1 is here, and the 2 is here, or the 2 is here, and the 1 is here, as long as somehow it equals the answer it's supposed to. That is what counts. So we have the 4 place right here, and divided by 2. Now we have only the numbers 1 through 3. You can also use these plus or minuses, or mark them yourself as you wish. I can't do 4 because a 4 is already in place. These are the possible numbers that could go there. Now, out of these numbers, the only way to get 2 using a division symbol would be 2 divided by 1. It doesn't matter which order. Like I said, it doesn't matter where the numbers get placed. It's the 2 and the 1 that are important here in this space. And by process of elimination, a 3 has to go there. It's the last one here in this row. Alright. Now this is a -1. Either a 2 or 4 could go here, because 4 minus 3 is 1. 3 minus 2 is 1. So we don't quite know what it is yet. But there are some tricks, playing this game enough, there are some tricks to know kind of where numbers can and can't go. And one of the tricks I'm going to show you right now is this +3. If you ever see a +3 in a 2 block, well, it will only come in a 2 block formation. It could only be 1 and 2. It's the 2 lowest numbers you can make. 1 plus 2 is 3. Hold on 1 second. No, come here. Is that better? Yeah? That was a kiss. Give that kiss. Well, fine. Bye. Love you too. Okay, sorry. So yeah, a 1 and a 2 has to go here. Well, also, if a 2 is here, a 2 cannot go here. So the only way to get -1 if the 3 is certain is with a 4. Pretty simple. And by process of elimination, a 3 has to go here. 12 in a multiplication with 2 spaces, it can only be 4 times 3. So it's gotta be a 4 times 3, and I'll mark it there just to remember. I'm gonna bring up the calculator right now, because I use this tool because I cannot calculate fast enough in my head. And my brother probably make fun of me for it. When I try to hold multiple things in my head, I cannot calculate. And I usually ask somebody to do it for me. So, right, I'm going to look at this 24 multiplication. I'm going to work backwards. So, I have here 24, and I'm going to divide it by 3. and we get 8. So with these two remaining blocks, we need to get 8. The only way to do that is by a 4 and a 2. And since a 4 already goes across this way, a 4 has to go up here, which means that this has to be a 2. And when you mark, these markings up here almost like in pencil, if as soon as an answer changes, like when I place, like this here was reduced to a 3. When I make this 3 here, this will say, oh, a 3 can no longer go here. So I put the 3 there, and it becomes a 1, as equivalent as this one became a 4. So if you lay out what the possibilities can be, you could start working your way across on solving these puzzles. Let's see, there's a 1, 3, 4, a 2 has to go here. 2, 4, 3, a 1 has to go here, and this one is a 3. And once you get it all completed, it says, congratulations. It's like, yay, you did it. Alright, so that's KenKen, and I usually like to play this for fun. I think I may go rather quickly. I'm going to try to explain what I'm thinking as I'm playing it, but sometimes I know I can go rather fast. I don't really mean to show you guys how to do this or how to be great at this. I'm just doing it because I can. So, with since it's a 5x5, there are 5 numbers, and this is a 4 and a minus. Excuse me 1 second. This is going to be one of the most unprofessional videos I ever make. And it's like the second video I made. Okay, since this is a minus, it's specifically a 4 minus, anything that is 1 less than the maximum number, just as with a plus 3, it will always be the highest number minus 1. It cannot be anything else. So, those are my 5 minus 1s. Let's see. Anything in multiples of 5 must have a 5, because 5 is a prime number. 5 can be a very important number. And I get 8. So I have a 5, which could go on this side because it can't go in here because a 5 is already up here. A 4 and a 2, but I don't know where that's going to go yet, so I'm going to hold off. 9, it's almost the same thing as a 3, only a 5 and a 4 can go there. If we were on a 6x6, it would be 11, which would be a 6 and a 5, so on and so forth. Kind of get the idea. Let's see. Here's a strange one. Now, since numbers can't go in a strange row, I'm looking at this row right here. This row of numbers. 4 and a 5 cannot be used. So what about here? A 6. Can you use a 3? No, because it would take 3 plus 3, which would be on the same row, so that doesn't work. 3 does not go there. 16. You can always check with the calculator if you're unsure. 16 divided by 3. It does not come out to an even number. So 3 cannot go here, which means the 3 has to go up here. And subsequently, this has to be a 1. The process of elimination gets this game to work really yeah, that didn't make any sense, but process of elimination, yes. Alright, 4, 5. It could be a 1, 5 or a 2, 4. I don't know, so I get to leave that alone for now. Actually, I do know. Nothing divided by 2, nothing with a 5 can get a division with 2. You would need 10, but you would need a 10 by 10, so that doesn't work. 5 multiply into a multiplier of 6, that's not happening. Since 5 cannot go here because of this column right here, 5 will go there, so a 1 will go there. There's a 4, 5, 3, so a 2 goes there. Alright. 16. Oh, this also answers another question. Back over here, we need a 5, 4, and 2. Well, that means that the 2 can go up there. We don't know where the 4 can go yet, so it's nice to make these notes whenever you can get them. Alright, 16 divided by 2. 8, so that is a 4 and a 2. We don't know which one it is yet, but because it's in a column, unlike this one which has multiple angles, which is what makes it difficult, here, 4, 2, 4, 2, it would work vertically. So 1, 2, we're missing 3, we have 4, 5, so a 3 has to go there. Now, because of the way this works, 2 cannot be there, so it has to be down here, and a 4 has to go up here. So a 4 also gets to go up here. Now that we have all 3 numbers, 5 is the only one that can go right here to solve for 40. So we put the 5 there. And then we start clearing out this. Alright. Oh, clear out over here too. This could be a 2 or a 4. I don't know which one that is, so I get to wait. 2 or 4. But a 3, since this one, see how it's only a 2 and a 4? I'm going to erase that because that's not how I like to remember. A 3 cannot go here because it doesn't answer it properly. A 3 cannot go here because it doesn't answer it properly. So a 3 must go down here. And so this must be 2 and a 1. Oh, must be a 2 right here because the 1's already right there. And a 1 goes up there. So that makes 6. And then eliminate the 2. So we go right there. 1, 2, 3. We need a 1. And then here's where you can use Sudoku. Where, like, okay, you only need 1 going across. 4 going across. Up and down is another 4. So you'd be a 2. You're a 5. And you're a 3. There we go. We just solved a 5x5 puzzle of KenKen. And yeah, just doing it this video for a little fun, little relaxation. I think I have enough time to try to speed through a 6x6. We'll see if I can do it in time. Let's see, a 6 and a 1 make 5. Another 6 and a 1 make 5. 20, so that would be a 5 and a 4 and a 1. 5, 4, 1. 5, 4, 1. Okay. A 2 cannot go here because you need 2 divided by 1 or 4 divided by 2, which does not work. Since they're already 1 and 4 already taken here, so I'm going to put a 3 and a 6. That's the only other possibility left, which means that this number is a 2. Which means this number, because these are minus 1s, this needs to be a 3, because this needs to be a 4 and a 5. Well, actually, that's one way of looking at it. The other way of looking at it is that there's already a 1, so to get the other way with the number 2, you would need a 3. But anyway, we get the answer. A 3 is already taken up right here, so it cannot be 1 and 3, so it must be 2 and 6. With only 6 numbers, it's the only way to get a division of 3. So since a 6 is taken up already here, this must be a 1, that must be a 6. Alright. Let's see, 3, 4, or 5, 2. Too many possibilities so far. Okay, 1, 2, 3. So we got a 4 and a 5 right here. 4 and a 5 make 9, so that leaves 5 right there. Okay. Sometimes you work on parts bit by bit because you just don't know. It doesn't always flow so smoothly. The 5 cannot go into a 36 division, so I moved it over here. It could be a 6 or a 4, but actually, if I'm right, 36 divided by 4 leaves us with 9, which would need a 3 by 3 multiplier, which you cannot do in a straight line. So a 4 is not valid in this area, so the 4 has got to go there, which leaves all of these numbers of it. I'm going to take out 3, actually 4, 5 is what I want to take out. 4, 5, because 4, 5 is no good. Now 1, 2, 3, 6. Well, let's do some calculating. Let's see, 36 divided by 6 equals 6. Now we need to divide it by 3 and divide it by 2. It's the only way we can get 36 with all of these possibilities. So a 1 must go here. That is what the process of elimination goes. You find out what these numbers are to help find a number over here. Then this gets to be 6. Sometimes it works that way. You never really can tell until you get around to solving it. Let's see. Where can I go? Of course, like any puzzle, sometimes you get stuck trying to figure it out, but that's part of the fun. Let's see. What can I do here? I wanted to speed through this, but it's got me stumped right now. Oh, I'm stumped so hard right now. Let's see. 4, 5. So 5 cannot go there. You can use here. Oh, I'm playing on KenKen.com, by the way. This is the website where I could. I'm sure you can find it anywhere else, but this is where I play. You can click this check button. If you have a wrong number, hopefully this is wrong, it will glow red when you click the check button. You know, so if you ever if you're still learning, you can kind of by some sort of deduction, it should be 1. No, it's not. Well, then figure out why it's not. If you just want to solve all the answers, you can just click reveal and then you'll be done. So you can do that if you want to. I won't judge. I don't care. Doesn't mean a thing to me. Man, I'm stuck. Sixes, can I go there? 4, 1, 5, 2. Well, let's see. We can do this. To get a divide by 2, you can either do 6 divided by 3, or 4 divided by 2, or 2 divided by 1. 6 is already used. A 2 somewhere has to go here. It has to go there. A 4, 2 cannot go there. Now let's see. 1 cannot go there. 5, 5 and 3 gives you the 1 and 3. 1 and 3. 5 would have to go there. 4 can go there. 1 and 2 could make the 5 and 3, which makes the 4 go there. Wow, I am stumped really hard right now. Okay, let's see. 14 minus 4 minus 5. 5. Oh, here's one of my answers. Since a 6 is not listed in any of these bottom areas over here, and by the calculations, a 6 will be too big for right here, and a 6 can't go there because a 2 has to go there, the 6 must go up here. So that's a small victory. 3. A 3 has to go here because it doesn't go anywhere else. So we have 3 of the 4 numbers. 14 minus 4 minus 5 equals 5, minus 3 equals 2. So there has to be a 2 in here somewhere, which means that this can't be a 2, which means that's a 2, that's a 3, that's a 2, which can no longer make it 5, 2, so it's got to be 4, 3, which makes this a 5. Alright, there we go. And then You can see everything's going good so far. So 4, 3, so 5. 5 and 3 have to go up here because a 5 cannot go into the divided by 2. And 3 would have to complement the 5. So that makes this a 4, which makes this a 3, which makes this a 1. That a 2, that a 4, that a 1, that a 3, that a 5, that a 4. And that's a 5 and 6, and that's a 5, that's a 6. There does come a point in the KenKen puzzle, like once after you get it, it seems that everything else starts to fall down and you start getting all the answers. Well, this could either be a 1 or a 4. That could be a 1 or a 2, but since this cannot be the important 2 in the equation, this has to be 2. That's gotta be 6, it's gotta be 2, it's gotta be 3, that's gotta be 6, that's 5, that's 3, that's 4, that's 5, 1, and I'm too lazy to actually look and calculate, so I just have it tell me what it is. And there we go! Finish the 6x6 KenKen in 10 minutes. I don't know if that's fast or slow, it's just how I did it today. But anyway, so that's me playing KenKen, just relaxing at home with my son, who's running around and screaming at the end of the room, if anybody can hear that. But yeah, so I just thought I'd make this video, me relax and play KenKen. I most likely will do this again, just at my leisure. It's just for fun, nothing important, nothing serious. So anyway, I hope you guys enjoy it, and I'll catch you guys the next time. Bye.